All right. Hello, everyone, and welcome to day 5 of RustLab. If you don't know me already, my name is Latara. I'm the talk manager for this year's edition. I'll be facilitating the sessions, break times, and so forth. So today we have for you a 3-hour workshop by Alessandro Pezzato, Create a Web App with Yew and Rocket. I'd like to bring Alessandro live before we get started just to give him the introduction. So let me turn on his live. Okay, while we're waiting for him to come in, I'll go ahead and read. Oh, there you are. Hello.
Hello.
Welcome to RustLab. We are so happy to have you here today.
I'm happy to be here too.
Yeah, definitely. So let me introduce you and what you'll be doing, and then you can get started, all right?
Okay.
Okay, so about Alessandro here. He is a former embedded software developer. He doesn't have huge experience on writing web APIs or UI. Nevertheless, he has found Rust and these two frameworks, Rocket and Yew, easy enough to create a functioning website without too much effort. And about today's workshop, we'll talk about how with Rust you can write both front end and back end. So in this workshop, Alessandro will guide you through the creation of a web app using Rocket Web Framework for API and Yew for a rich and interactive UI. With Rocket, Yew and Serde, we'll explore the type system to have secure authentication and a terse code base. In this workshop, the speaker will allow us to see how to create a rich web application and why Rust can help developers on writing secure APIs while also keeping the code very terse, fast, and reliable. So we'll start with the introduction and get started.
Okay. Your introduction was perfect because you have said all I wanted to do to say about Yew and Rocket. I've used it them with my project, my open source project. It's a website, Dev and Dev. It's a website where software developers can meet to schedule some pair programming session. And despite I haven't so much experience with web development because I'm a former embedded developer, I was able to create in not too much time a functional website with Yew and Rocket. So I will guide you through this adventure in the next 3 hours. And we will have at the end, I hope, something that can be a project, a simple project. You can continue to grow for a real world web application. So I see 20 participants. Okay. These are my contacts. You can find me in GitHub. I'm Alepeth on Twitter or on LinkedIn. And we will start soon with our projects. And I will ask you to download a project from my GitHub. It's a starter pack for Yew and Rocket. There are just some few lines of code, and I will explain all of them. So I put in the chat the link to my project. You should have received an email with the prerequisites. So we will use Linux with your favorite your favorite IDE or editor. You can use whatever you want. It's better, I think, Visual Studio Code or CLion, because it has wonderful integration with Rust. Are you ready? You can just write in the chat if you are ready to, and you have all the tools. If there are any problem, you can ask me in the chat right now, and I will guide you to have an environment which you can use for working. Okay, I think all of you are ready. All good? Okay. Okay, so if you have downloaded the project, Rust Rocket Yew started from my GitHub, we can work on it. Now I'm going to share my screen so you can see the exact same code as you have just downloaded. One moment. Okay, so here we are. This is the Rocket main. But we can just close it and see which is the structure of this project. If there are any issue with the font, just let me know, because I don't know if it is big enough to be seen. Okay, I think no problem. So the structure of this project is this. We have two directories to create. I've called it album server and album UI because we are going to create an image album. In album UI, we have Yew source code and all the code which will be compiled to WebAssembly. In album server, we have the backend, so Rocket source code. Here we have a static directory, but this one is just automatically generated. We only have one file, main rs, and one cargo toml with the dependencies. About the UI, we have two Rust source files and a little HTML and some style sheet. But first, we are going to see what happens with Rocket. So this is the main. Just 39 lines of code. And there is all we need to have just one page, hello Rocket, and handling of static files. Okay. At this point, if you have the right toolchain, now I have 149 nightly. I've tested it even with 147. We need nightly because Rocket uses some features that are only available in nightly. I think that with the last stable version of Rust, these features are available, but Rocket still require a nightly version. So if you have all the toolchain and the project, you can just go to this directory, so the root of the project, and launch Argo Run. Now, I've already compiled the project. It will take for you some time to compile, depending on your CPU. But at the end, you have a web server running, and you will see at this page rustlab.pets.me port 8000. Hello Rocket. Okay, this is my this is my server, the server where I'm developing in this moment, because this Visual Studio Code is connected remotely via SSH. So all I'm doing here is just published on this server. So if you go to your localhost port 8000, you will see this website. If there are any problems, just write in the chat, and I will help you. Now, what is this code? We have a main, and it's just I think many of you knows what this is. This is starting the login system with the env logger, and then there is this function ignite and launch. Ignite is this function above. It's called ignite because there is a function in Rocket called it ignite, and I'm just calling it, so I've called it the same. Rocket Ignite just creates a Rocket instance and let you do something on it before launching. The launch is done here. Okay. Later it will be more clear why I've used two different functions, ignite and main, because it is useful for testing, but we will see it later. So at the moment we don't know what this is. And I will explain later. This, instead, is just saying that all the routes described here, this is a macro routes that create a collection of routes. And a route is just one function with some special attributes, like this one. These are a special feature of Rocket, is where all the magic happens. The magic will be still magic after our adventure today, because I don't have time to go deep and explain what is happening here. But to be clear, here we are just saying that this function is the handler of a request, a get request with a get method to this URL. And this URL is just under the root URL. Okay, so if I make a request to HTTP localhost 8000 / this will be the handler. This function will be the handler of the request. If, for example, I change here and say foo, then I will reach the page, the handler, at this URL. This one instead is the parent folder of this route. So say here I place this one. To reach this handler, I need to say this. Why is this useful? Because if you have more handler, they are all mounted. This one needs another name. They are all mounted inside these. So index will be reached using this URL, and index 2 will be reached using this URL. So this is what mount is doing. Is just mounting a collection of routes in a place. But now we can just delete this and try something new. Okay, cargo run isn't the best to use during development, because you have to stop it and relaunch it when you change something in the code. So I prefer to use cargo watch and say watch changes to this directory and run when there are any changes. So if now I change the code, everyone, it will be recompiled, and hey, not what I was expecting. Yes, another magic. This is due to a static file and the one above. So there was a mistake. Here I need to have only the slash. So, hello everyone. There is something in the chat, sorry. Oh, somebody's saying, with cargo run, I catch blocking waiting for file lock and build directory. Okay, I think this is because there is also Rust Analyzer behind. And until Rust Analyzer hasn't finished to build the code, there is a lock. Yes. Okay, just like Steph Jones said. Okay, so I think everyone is at this point. So you have a running web server. Perfect. What happened when there was a typo here, a mistake? There was foo written here. We see that. Oh, just for a moment. It is reloading, I think. Okay. We see hello you. Why hello you? Because there is these static files. It's called fairing in Rocket words. It is fairing. It is a way to handle things differently than having an endpoint or route like this. It is something that changes the behavior of the web server. In this case, I'm using this fairing. It's called static files and is in Rocket contrib crate with some extensions of Rocket. This fairing is useful because you can just say takes all static files from a specific directory, and when a request is done for something that matches a directory, just give that file. So here we have a static directory, and there is some HTML, some style sheet, some JavaScript files, and the wasn't the WebAssembly application. These files are generated by the other crate, album UI. I think that now I can just delete this folder because it will be recreated later. So what will happen if now with this route changed and no static files? I think that there would be a 404 not found, because now we don't have any route for the index page, and we don't have any index HTML file in the static directory. Static directory was called a static, but you can call it whatever you want. The path of this directory is just created here. It is just the directory where the crate is plus / static at the end. So this snippet code we don't need to investigate more, but it's just creating a way to provide static files. Okay. Marco asks to put ensure static files are Rocket's RS caching mechanism. No, it's just a way to let users download static files like CSS or JavaScript. So they are files that are already available. They are not dynamically generated. They can be HTML files or images or CSS normally. They are just files that are already created. Okay. Why I've said that they were created by Album UI? Because we have two applications here. One in the backend that runs on a Linux server, and one in the front end that runs on your browser. Yew is in charge of creating the WebAssembly, CSS, and HTML files that when the Album UI create is compiled are generated, and we treat them as static files because they are just like a JavaScript asset or a style sheet asset that the web server will provide when requested for the URL. Okay, I don't see any questions. So, yes, there is something that I haven't said yet. Here, I have a rocket toml, which I can see. Okay, I needed to refresh. I've just added this file. It's rocket toml. It's a file where you can configure some behaviors of Rocket. In this case, I've added this address and this port. I think the H1000 port is just the default one, so I can even delete these. But address here is needed not by you, because you are just connecting to localhost, and the default value of this configuration is exactly localhost. I need this one because otherwise you won't be able to reach Rocket from this address, because this is a real server. You can just try to go to this URL, and you will request pages to my application here. So if I change this one to localhost or just to empty, here the website shouldn't be reachable. Oh, I don't know what is happening now. Maybe I have even an environment variable. Okay, I don't know for which reason, but the default behavior is to not expone the web server on all addresses, but only on the localhost. So if you want to publish it, you have to create a rocket toml. You can even have different configuration, one for production, one for development. You just say production here, or development to change some behavior. For now, I will have a simple file with global and this address to have the web service exposed to the public. Okay. So this is Rocket, just one main with 38 lines. And now we can go to see what is happening in the front-end side. So the front-end is not an application. You don't, sorry, an executable. It's a library. You can have different ways to compile a Yew application. I will just show you what the Yew documentation is saying. You can have, you can use cargo web, cargo bindgen, or wasm pack. There are different, there are different ways to compile a project written in Yew. All of them have some pros and cons. I've decided to use wasm pack because I found it simpler to do. So I don't want to say more about this. We will go with the wasm pack, and I will guide you through that. What do we have in this project? Node modules and PKG are automatically created. Static here instead are not generated. They are written, but are very simple. There is an HTML that is in charge of just starting up the application, loading this JS. This JS still does not exist because this JS is actually generated. And there is a style sheet. Even the style sheet will be won't need to be deployed to the web server because it is included in the generated JavaScript. It's a little strange, but it is so. This isn't a CSS, but a SCSS. You can even use CSS. We will see here in the Webpack how it works. Bootstrap.js is something that you take as it is and you place it here, because it is needed by Webpack. Webpack is a program that can deploy, can pack all the assets you need in the front end to have something to deploy in the web server. And here, I don't want to go too deep here, but if you're if you already have developed with Node.js or JavaScript, I think Webpack is something you know. But in this specific case, Webpack is using a plugin. It's called wasmPack. And this plugin is used to take the code, the Rust code here, compile it with cargo, and then produce a wasm binary to be deployed. We have two configurations here because later you will see that we can have two different workflows. One where we build all the files and use Rocket to make them available to the browser, or we can just use directly Yarn. It's a package manager for Node.js to start a simple web server with a live reload. So when you change something in Rust code, the website is automatically reloaded. In this case, it's called the development configuration here. It doesn't even need a Rocket web server behind because it's all working from the front end. Maybe I haven't been so clear, but you will. It will be more clear later when we will use it. So this Webpack config, you just take it like it is, and it is in charge of pre-compiling the CSS from the SCSS files and compiling the WebAssembly from the Rust source files. And how can we use it? Okay. Now I have a terminal here below. I have multiple tabs. It is done by Tmux. It is a terminal multiplexer. There are two ways to use these to see what is happening on the front end side. So the two configuration. The simpler one is yarn run build, and we'll build the production configuration. It is just compiling Rust code. It was already compiled, so it has taken a few seconds. In your case, it will take, I think, a couple of minutes or less. And it has created some files here. So Bootstrap is exactly the one was here in the project. And then it has created index.js and index.bg and bg.wasm. Then all these files are bundled in another file. It is called app.js for the JavaScript, and I don't remember the name. I think it is app.wasm for the WebAssembly. The JavaScript code is very little. No, you don't need to write JavaScript code at all. It is just something that is generated to bootstrap the environment where the WebAssembly can be then loaded. So now that we have called yarn run build in the album server, there should be a static, okay, it has appeared here, a static directory. I don't think the style SCSS file is needed here. We can just remove it. But when you have yarn run build, you should find at this page index.html exactly this index.html, because it is handled by the static files failing. Okay. If there are any questions, I think it is the right moment to do, because I will need a little pause in about 10 minutes. I think all we will have a pause, a 5-minute break. So if there are questions, okay, there is a question in the Q&A. Is it possible to extract the call to routes to a function? Yes, yes, it is possible, and we will do it later because routes will become more than one or two. So yes, it is possible. You can even create other modules, other source files with a collection of routes which explain a collection of routes. So you can just import with the use keyword these modules and their routes from these modules. We will see it later. It is in my program, so yes. Other question? Okay. Oh yes, I needed to run a yarn install first. Right. Yes, run install. I think it was even in the README. If not, okay, yarn install or maybe even npm install is do the same. Yes, yarn install is more correct. Chris Greenaway say I have to work out how to install yarn. Okay, I think you can install it with the package manager if it is in your system, or with some script you can download from the yarn project. yarn.pkg, getting started, installation. You can install it with npm. So if you have npm. If you don't have npm, you can install npm with a script for npm, and then you can install yarn. Okay, we are Rust developer. Maybe not all knows what npm and yarn are. They are Node.js JavaScript package managers. Okay. So you need also Node. I haven't said it, but yes, you need a Node.js to be installed. I think that you can find a lot of documentation in the web about how to install Node.js, npm, or Yarn, and it depends on which operating system are you using, and in Linux it depends even on which distribution you're using. Marco Gazzin asks, why do we need Node.js installed? We need it because Webpack and Yarn are used here to process some files like stylesheet, JavaScript, WebAssembly, and bundle them to be deployed. I think that you don't need Node.js if you want to do all of this by hand, but it would be a tiring experience. So I suggest to just use install Node.js and use these tools to deploy the generated files. Paul is asking, once npm is there, it should be available. Oh no, okay. It's just an answer. Okay, perfect. If there aren't any other questions, I think we can take the first break.
Sounds good. All right. Well, as you heard, everyone, we'll take a 5-minute break. We'll be back at around 21 past the hour. So see you then. Have a good break. All right, you guys, we are ready to continue. So hopefully you had a wonderful break, and let's take it away with Alessandro. When you are ready. There you are. Okay, take it away.
Okay. I will give you another 30 seconds to come back from your break. Okay, so I was saying that you can build with yarn around build. I hope everyone now has Node.js, yarn, and all the tools needed installed, so you can play with Yew. And you can even play with the Yew live reload. The command to launch a version of the front end that doesn't even need a Rocket web server to be loaded by the browser. You can use yarn run start dev. This command will compile the project with development configurations. For example, it doesn't optimize the code, the generated WebAssembly code. But the most useful feature of this mode is the live reload. Now you should have at this URL web server, and it is just provided by the yarn run start dev. As you see, the process is hanging here, doesn't exit it like the build command did, because here it is waiting from requests from a browser. So now I go here. In my case, it is localhost. I have already created a port forwarding to the server I'm using. In your case, you don't need it because you're doing development in your local machine. In my case, I'm doing development in a remote machine.
Hello, Alessandro. Sorry to
Hello.
interrupt. It seems that nobody can see your screen. Can you please share it?
Oh, sorry.
No problem.
Okay.
Great. Thank you.
I thought it was sorry. Perfect. Now you should see it. The command I was talking about is yarn run start dev. Okay, so if you launch it from your album UI directory, it compiles your project and it starts a web server. We don't need the other web server, the Rocket one, so we can even stop it. In your localhost port 8001, you should have the server available, and it says, hello, Yew. In your case, you have it in localhost. In my case, I'm developing on a remote host, but I've just forwarded the port, so it is available in localhost also for me. Yes?
Hi, so sorry again. It seems that the share screen is cropped. Is it possible to share the full screen? People cannot see all of the code.
Oh, okay. Strange. Now,
For me, it's good.
okay.
Okay, perfect. Thank you. Sorry to
Thank you.
interrupt.
Okay. So now you can work on this. I put for a moment the browser and the editor on the same page, so we can see that something is changing here. Oh, I can just take a new tab. Okay, not what I wanted to do. Okay. And these with the editor. So if I go to album UI source app rs, where our app, where the source code of our app is, I can change it and say, I don't know, hello people. Save it, and here below you see that something changed, and the live reload automatically reload. I don't have touched anything except saving the file. The live reload has triggered, and the page has been refreshed. So I suggest you that when you are working just on the front end, to use the live reload of Yew. So yarn run start dev. It starts a web server. You don't need the Rocket web server to be alive, and you can just work on your front end. There are a lot of messages. Okay, about Rust version. Okay, well, I think there aren't problems. So this is an application written in Yew. Not too much code, about 30 lines of code, and you have a start, something to begin with. But we haven't seen yet what librs contains. Librs contains is even smaller, and we have some boilerplate, but very little boilerplate. It is just saying that this function is the entry point for wasm bindgen, and it is the first thing that will be run after the wasm bindgen environment has been created in the browser. So you don't need to touch this file, except if you want to do something strange or more optimizations. For example, if you want to change the dynamic memory allocator to be more if you don't want to use the standard library one, because there are memory allocator more powerful for the web environment. I think just because they are cheaper. But anyway, you don't need to touch this for this workshop. So we just close it, and I will only say that it is starting a Yew application providing this component like the first one to load. This component is this one in the app.rs file. This is the module, this is the struct, the component. What is a component? A component is a piece of the UI that can have a state, can be changed, and can be viewed, can be rendered to HTML. Actually, it isn't rendered to HTML in a strict way, so it is not. It will not create HTML strings, but it will modify the DOM. But anyway, I don't want to go too deep to the low-level details. So up here is, for the moment, is an empty structure, but implement the component trait. The component trait is a trait you can find in Yew. If you just import Yew prelude, everything in Yew prelude, you have also component. It is a trait for anything that can be displayed on the page. And you need to implement some functions here. These functions are all you need to have a working component. And depending on which kind of component are you writing, you need to implement them. Normally, you always implement something. You write something in the view function because you want to see your component. So in this case, the view function is the one that generates something to be rendered by the browser. And you see this strange code. What is this? This is not HTML. If you ever seen JSX, the React.js, in React.js you have JSX. It is a kind of HTML that can be embedded in JavaScript. Here we have a similar thing. We have a Rust macro that takes something that is similar to HTML and render it. Generate this struct that is something that the Yew runtime can take to display it in the browser page. So what have we done here? We are saying that we want our component to be a div HTML tag with some text inside. You have to place the text between curly brackets and quotes. HTML will be this, but this is not a real HTML. It is something that the Rust macro system can understand. So we have to put curly braces and quotes. The update function is the function that will handle messages to this component. And later it will be more clear. The change function will handle changes to properties of this component. In this case, because the component is the root component, the one loaded by librs here, we don't pass any properties. Later it will become clear what properties are. And create is the function that, which is called when this component is created. And as you see, there are two parameters here, props and links. Properties, we don't need them because it is the root component. And link will be useful later. For the moment, we don't think about this one. We have also to implement two types in this trait. And we just say that message for this component is this enum, and properties is the unit. So it doesn't have properties. This component, because is the root component, doesn't have any properties. Later will become clear what I'm talking about, properties. Okay, so now we have to write some code. And we want, for example, let me see what was the next step. Okay. Okay, now we can come back to Rocket. Then we will have some work to do in Rocket before starting doing something useful in Yew. So for a moment, I close the server here. It doesn't respond. Okay. I open the main. I launch cargo watch run. And I try to do what I wanted to do. Okay, so as I said at the beginning, we are going to write an album web application. So an application that shows images. You should have already downloaded some images from datasets, but the one I suggested is one that you can use whatever images you want. And what? We want to provide an endpoint URL where you can load a JSON describing all images in your collection. So I fix the route here and add another endpoint. When you add another endpoint, you must use, because it is a function, a different name. So for example, we call it images. We put it in a different URL and call it images. And see what happens. It won't happen anything here at the moment because the route hasn't been used. So we have also to add it here. Okay. So now I bring the browser. Okay. Is the homepage, and here we have images. Images, but we don't want a text here. We want a JSON. So there is already bundled with Rocket a structure in Rocket contrib. So I will just add Rocket contrib here, JSON. Structure called JSON that automatically generates a JSON from serializable structures. But which structure can we make here? Okay, for the moment I just place string that is something serializable. I put JSON. Okay, because it is expecting a string, right? Now it should be in quotes because it has been serialized as a JSON. Okay, this is valid JSON. It is a string in JSON, but we want something different. We want to have something to describe images. Okay, in my mind, images for the moment are just IDs of images, so numbers. But because we are using Rust and we have the power of types, we create a new struct with something in it. It will be simpler having, for the moment, just the file name of the image. Okay. Now, I don't want only one image, but a collection of images. So, for example, I can create a new type called images that is just a vector of image. And we try to respond with something. But images, it is saying, cannot be serialized because it doesn't implement Serde serialize, and it doesn't have a default constructor. So, magic. We can just automatically derive it, and we need it even for image. And we need to get Serde serialize. And we need it also in cargo. Here. So, I think all of you already knows what Serde is because it is a really useful crate. For the ones who don't know it, Serde is something that help you serializing and deserializing things, structures to different formats. So in our case, we are serializing to JSON. And to enable structures to be serialized, we can just implement, it can be also automatically implemented with the derive serialize. We can implement, automatically implement a way to serialize this thing. Serde do all the magic and creates something, the actual JSON generated will be something similar to this structure. And we will see it. Okay, unresolved? No. It's running, so I think it's just the analyzer not working. I also implemented the default constructor, so now it should give us an empty array. Why? In JSON, we have an empty array because images default use the vector default constructor, and the default constructor of vector is an empty vector. And when you serialize with Serde vector, you get an empty vector, you get an empty array in JSON. Okay, I try to close and reopen main.rs because it is saying, it is giving an error, but it isn't actually an error because it is compiling fine. So I don't know. Okay, next. We will keep questions for later. Okay, it's better to give some fake data here instead of an empty array. So I just add simple function, for example here, and call it instead of giving a default. So this is an image I have in my PC. And now, as you say, we have the magic happening because a JSON object has been created from a Rust struct. But what about tests? You know that having tests is good because if you can change code later and be sure you haven't break anything. So we can add a little test here. To call the test, I can just say cargo test. Okay, failed, it says, and it gives me even the reason. I was expecting an OK status, but instead I've had a not found status. And you know why? Because here I put API images, while here I have images. So I really want to have JSON API below the API folder. So I can add API here. Cargo watch can be used even with test. So it tests, and if all tests are green, then it launches the web server. Okay, now tests are green, but I'm sure I will have more API endpoints. So, do you remember the mount command here? We can add a new collection of rows. We put them inside the API folder, and here we call API function. I put it here for a moment. Error. Yes, it isn't exactly what I was trying to do. Images here. Remove images from the other collection of rows. It is expecting a different type. Oh, I think there is rows. Okay. Better. Now it compiles. What have we done? Yes, now images doesn't need API in the URL because it is automatically added by the mount here. So we have done some refactoring, and even more, we can add API RS and put all our APIs here. So node API. I changed the name to routes because I'm moving these here. I need to copy all of them. Then I will let Rust Analyzer tell me what is needed. I can even move structures. And call this one routes and publish just this one. So I published just the routes. All is hidden in this module. Now it compiles, yes. This one isn't needed. And this isn't needed. So after some refactoring, we have APIs just in their files. And this is still, no, it is not working because we have to change the URL. It is working, perfect. We talked about tests. it was here, but this test is about API, so I can even move the test. Here I have to go up one more level to get Ignite. And now I can explain you why in the main the Ignite function is not just inside the main. Because for testing, we can create a Rocket instance without launching it. And it is useful because we can get a client, a mock client from this Rocket instance, and use it like we would use a browser to make tests. We can use this client to make requests to Rocket without having actually a web server with an open port, with an exponent port. So tests can be automated. Okay, now I don't know why it compiles well, but cannot run from this. I think I have some issues with Visual Studio Code because it is testing and compiling fine, but I cannot run tests. Anyway, now we have some APIs to work with. But having only information about which images are in our folder isn't enough, because we want to get those images. So we need something to download those images. And we can use another endpoint. So I just copy paste this one. Say that we want to download only one image, but which one? We put the ID of this image in the URL. The image will be called preview.jpg. This function needs to be renamed, and for example, can be image preview. And it doesn't give us a JSON. We want to download an image. And what is an image? It is just a bunch of bytes. So we say that we will return a bunch of bytes. Or better, a bunch of bytes, but maybe there can be some error because these bytes must be loaded from the file system. So we wrap this bunch of bytes inside our standard I/O result. Why standard I/O result? Because if we want to load the image, we use standard fs read. Read takes a path and give a standard I/O result of bytes. And this is what we need to load something from the disk. The path here is hard-coded, and not the right one, but okay. This is the directory. And this is the file name. Here it is, so the image exists. Wait, here we have something dynamic. We have a URL which a parameter, and this parameter can change. But Rust is saying that there is a problem. Unused dynamic parameter is something. This is an error from the Rust system, the Rocket macro system. So, what do we need? We need to say that ID is just a string. We are not using it for the moment, but we can use it. Sorry. We can use it here. Yes, okay. It's a missing parenthesis. So, what will happen if we put here something /preview.jpg? 404 not found, but okay, this is a valid ID. What happens if here I put a number? I'm not sure it is valid at this moment. This exists. Now it should download the image. JPEG. Is it downloading something? Oh. API images. Oh, something is missing. Yes. Because we haven't used yet this in our roads. Okay, now it is downloading an image, and it should be a dog. Yes, not my dog, but it is a dog. So now we have something to give images to our front end. Okay, there is a comment here. I cannot build around from the server folder or only from the upper one. Okay, strange. You should be able to do it from both, but just do it from the upper one. It is okay. Okay, this is very ugly, so we can do better. I think that the path to the image should be provided by the image. So I just copy paste from my test project what should be the path here. Okay. Okay. File name. Here I have file name, but here I have ID. I don't want file name. I just need the ID. I can get rid of file name and just use self ID. Wait, but we have to change the fake with something that should give the same result. Oh. Okay, so after this refactoring, I don't need to repeat the code, but it can just be let path equal image. We have to create an image. And ID here is a number, is always a number. So we can just change string with usize. And the rocket is doing the work for us. It parse the string present in the URL, and if it can be parsed as a number, it call the handler. Okay, it is downloading. See what happens if I write something that cannot be parsed as a number. Not found. Here we are seeing what Rocket calls request guards. So if you have parameters here, Rocket makes sure they are good. You cannot have something that isn't a number here. So if you pass something that cannot be a number, the handler isn't called. It isn't just called. You get a not found in the, for example, because there isn't an endpoint here that handles something which is not a number. And this is the most powerful feature of Rocket, because here we have something simple, but with authentication, it gives you superpowers. Okay. Yeah. Okay, shouldn't that be in an input block? Or maybe because I was writing something stupid some minutes ago. Okay. Okay. Just one moment. Okay, here I know where images are. We should place this path in another way. For example, it may be relative to the crate, or better, it could be an environment parameter, or it could also be in a Rocket toml file here. I let you try whatever you want. Now we can just keep it hard-coded. Okay. Now we have fake data here in the list of images. What if we have real data? So we have a list from all images in this directory. It can be done, sure. We just need to implement something. For example, I have a snippet of code that I just put here below. Okay, we can just paste a path. We need also something to parse the ID in the image. In the image name. Okay, I will create a from ID because I use it in the other code. Yeah, path. Okay. I don't explain what it is doing, but it's just scanning all the contents of the path and giving a list of images. And this parse ID just takes the name of the image and extract a number. If you are using different images or a different data set with names written in another way, you have to change this function to parse the correct ID from your image. So I just replace fake images, which is used here, with list images. Oh, I have to pass the path. expected start images. Okay, fake images gives images, while list images gives a result. Okay, no problem. The problem here is that fake just gives a collection of images, while list images may have some errors, and this is why it is wrapped in a result with standard IO error as an error. So we can do something stupid, like calling unwrap here, and now it should compile. It is stupid, and we will change it as soon as possible. Now we have a list of all images in my folder. Okay, we already seen error handling on Rocket. We can keep it simple and say option instead of result. Make the code more clear. Use the question mark operator to early return in case of errors with none, and just return JSON images. Some JSON images. Yes, we have to translate the returned result to an option, so it can be early returned from the function. So what happens on success? It gives us images. If the directory, for example, doesn't exist, we get a fail here, and just tests are failing. But if I run without test, it gives us not found, because when you return a known from a Rocket handler, Rocket responds with a 404 not found. But replace it with the correct directory. Okay. If there are some questions. Okay.
All right, I think we are ready for our next 5-minute break then, yes?
Perfect.
Wonderful. All right, so everyone, we will be back here at 25 after. So see you then.
See you then.
All right, here we are back from our break and ready to start the last part of our workshop. So let's have Alessandro back on. Here we go. All right, welcome back and good luck with the last part of your workshop.
Thank you.
Mm-hmm.
Okay, now I share the screen. Perfect. So, I just move list images here. No, I will do it later. It's not important. We have to go back to Yew now because we want to see these images. So, how can we do it? Just see. We have to write some components. For example, we want to show some images here in this view. But first we have to load them. How can we load something to the Yew to the front end from Rocket? We have to use what Yew called a worker. A worker is something that can do tasks, and in our case, tasks are just fetching data from the web server. I will create a file. I will create a file and call it worker. But first, let me say that, yes, one moment, I launch the local server for Yew. And I see that at the beginning, we have a state where we don't have yet downloaded the list of images. So, what is better to see? We just say loading, because we don't have any images. We have a state at the beginning when we don't have images yet, nor a list of images. So loading is the perfect thing to say. I have said we have a state. And what is a state? Is something that describes in which state is your component. In this case, the main application. Let me add a structure called state and say, for example, images loaded feasible, or better, why not? Images is just something that can be or not be, and it is an option. An option of what? Of images, for example. So now you say these images is in the album server, but we don't want to import album server to the front end. It doesn't sound good. So we add a new crate with common code between the server and the UI, because these structures, like images, are the common data shared between the two applications. So I will create album DB, for example, and I place here cargo toml and some source. And wait, we have to move this structure used by both by the server and front end here. And this is very powerful because we have only one place for the shared code. Okay. Sorry. Okay, okay. No questions. Perfect. Okay, we were doing some the new crate. And we need the cargo toml here. I just copy paste it. We need Serde, rocket, but it's optional. And I will explain it later, the logger and the logger. And here, from cargo toml in both UI and server, I need to add the new dependency. Because it is a local project, I just say get it from the folder above. Okay, what is happening? Cargo. I've made a mistake. Cargo toml. Oh, I just added the dependency to the wrong cargo toml. I miss something. This is album DB. Okay. We have Serde. Now, yes, it was missing a feature here. And we need even in the UI. And we also need to add DB here to the workspace cargo toml. Now I have to explain why. If you want to help, okay, why it is saying can't find the right macros revising the scope. Album DB source lib, album DB source lib. Oh, right. Use Serde serialize. Okay, and now just fix the import of this must be publish. Oh, I've added publish to the wrong place. Album UI. Okay. And this is server API image, right? When we do this kind of refactoring, we have to change the visibility of methods. Okay, so still in API-RS. Structure is visible here due to bright fields. Okay, right. It should be from ID. And also this must be okay. It took longer than I expected. Perfect. So, come back to you. I hope it will compile. Okay. So, I was saying that now we have an option of images because images at the beginning aren't fetched yet. And this state should be in our component. So just add the field, type state. Automatically implement the default state. And here we create it. Okay. So we have to use this. I think that we just need to display loading when it is none. And display the images when it is some. Okay. So we have to go the object inside. These must be taken by reference. Okay. Loading. Okay. We have to load something now. And now happens the hard work because we have to implement the worker. So you know what? I just copy paste the worker because we don't have too much time to write one from scratch. So give me a moment and I will add it. I've added a new module, call it a worker. How do I worker? Oh, worker. I just comment out something that we shouldn't have yet. Okay, what is doing this worker? This worker will receive messages from components and do something when the right message arrives. Worker is just the name I've given, but it implements the trait agent. And an agent, like components, receive messages, but also have an input, an output, and a reach type. The input and the output here are these two enumerations, request and response. And they are what is exchanged between the components and the worker. So, for example, when we want to get the images, we give we send a message to the worker with this request, and then the worker, after has correctly fetched the data from the server, respond with a response and with some data inside it. Here there are some boilerplate to have this worker available in all components with publish subscribe pattern. I will just try to make it compiling. Okay, so we are missing something. We are currently importing our solid import AutoDB. I think there is something with the Visual Studio. Okay, I have to add this type here. I have to go faster than before. Okay, don't mind. I've added something more, but it should work. And we will see. Okay. Wait, where is my terminal now? Here. Perfect. Too many compilation error. No, I have too many changes. Okay, sorry. There are too much code changes. Yeah, there is a question. What does workers do? Workers are like a separate thread. In this case, is not a real thread, but you can have real threads with web workers. And in this case, is something that can asynchronously fetch from the web using a fetch task. We'll show it later. And so when the UI have to wait for a response from the server, it isn't blocked. So the UI just pass to the worker, do this, and when the worker has finished, just send a message to the UI with the fetched data, for example. It can do many other things, but we will use it for fetching data today. Okay. What time is it? Too late. I think that it's better to just see the resulting code, and I will describe it to you. Otherwise, it will take too much. So let me just upload the finished code. Okay. Okay, here we have the project like it should have been at the end of our adventure. I'm sorry, but it took so much more time than I expected. Because I also want to show you the authentication. So, what happens at the end of our adventure? We have our main application in Yew with the state, the component link, which is used for buttons and other interactive components. I now explain. And the worker. Actually, this is a bridge to the worker. So the worker is an instance, and this one is something that can send messages to the worker. It is not actually the worker instance. Okay. Yes, the path of... I have an error because it is looking for images in the wrong path. And the path is here. No. Okay, strange. Yes, I missed this. Oh, sorry. Why it isn't working? Oh, this was wrong. It's rocket address. Here we are. API images. Okay. You see unauthorized. And here we should see, yes, because we are missing the UI now. Okay, I've just copied the project as it will be at the end, and I need to install packages. It doesn't change it too much, but for example, now we have authentication, and we have the images loaded. So I just for a moment show you the end result, and now I will show them. And then I will show you the code. So I'm just rebuilding the WebAssembly application, so it is available from the web. Okay. And about the worker, well, okay, it has compiled, so now it should be visible here. Here we have a login, put a password, and here we have all the images loaded. And we can change something. It's not too much code more than before, okay? So we will see how these buttons are created. For example, we go to the main application, the state have images with an option of images. Here I use a reference count because it can be copied cheap at a cheaper cost than the whole vector of images. And what happens when the main application is created? We create the worker, and we immediately send to it a message that we want images. The worker here will receive to the function we have to implement, and it is update. It is handle input. It will receive a message, the message called worker request get images, and it will handle this, creating a request to the server. Okay, this is some boilerplate of code. Here, this is the working one, where for each type of request, we create a new task. New task is created here. You can just copy this function without knowing what it is doing, but it just create a new fetching task. Fetching task is something that Rocket gives you. Yew gives you. Fetch task is something that communicate with the browser fetching capabilities. So it requests to get a page or some data from the web, and after it has been downloaded, it finished, and at that point, and we see it here, this is the callback called when the fetcher has fetched data. And when the data is fetched, if there is something useful, send a message to the worker, not to the component, to the worker with the new data fetched. Otherwise, if some other error, it sends a message with the error. The worker at this point receive this message here with the response, and publish it to all listeners. In this case, all listeners are the main application component and other components that we have created. All components receive this message. In this case, the application will receive the message in the update function with a message of the worker response with the response, and the enumeration images loaded with the actual images loaded inside. Here images are not the the JPEGs, but just the images structure that we have here in AlbumDB. I'm going too fast, I know it, but we don't have too much time. Okay. What about these buttons? When the application is created here, automatically request for the images. So for some milliseconds we have loading, and then you have all the images. This is triggered by this worker send get images. But we can interact with the application in other ways. For example, here in the view of the main component, we have, if there are images, we show there are images here. And for we iterate on the images vector and map those images in the vector to components. So if we have 96 images doing this, we will have a vector of 96 components of the preview type. Here we have the usual HTML macro. This preview type is written by us. The preview is in this module here. And is a component like app is. So it implements component, it has messages, properties. In this case, properties are used because unlike the main component app, here we pass some properties. Properties are something that is not a state, cannot be changed directly from the component, but only by parents. So, for example, when here the preview component is just this box with the image and these buttons and apps if we have them. This is the preview component at work. For example, the property here is the image to be displayed. In fact, here props have just the image. And the image is just a type with the ID, the number inside, and some functions. This is the constructor of the preview component and is instantiating the state of the component because this component, for example, has a state that say that the tag input is visible. The tag input is visible when I click tag and become invisible. So this is set to false when I click cancel. And there is the tag text. This is the state of this component. The state is something that can be changed inside the component. The props cannot be changed. The change function is called when properties changes. So the component isn't recreated, but isn't recreated, for example, when the parent component changes the properties passed to this component, but only if the component needs to be re-rendered. In this case, we are saying that the components needs to be re-rendered every time the passed properties are different than the already present properties. And we use this one. Neck assign is a function that can be imported using the create util, and there is neck assign, and is something better to write than like self props, in this case different that props. It is simpler, but you can even do this in more fields, and using ecosign is usually more clear than using other type of checks. This is not the perfect example, but I find it very useful in other contexts. I was saying about the buttons. Delete here is just an HTML button. It is created with the usual HTML macro, but the callback, this is a typical callback of a HTML button. Here you just say that this callback do something, and this something can only be send a message to the same to itself, to the same component. Send a message. In this example are accept tag clicked, and this is when I click OK, or cancel tag clicked when I click cancel. This tag button instead is here, and the callback is add tag clicked. See what happens when add tag clicked is sent to the component, to itself. Update is called, and the return of this function should be a boolean, true or false. If true, it means that the component must be re-rendered. In this case, when we click tag, we change the state of this component, and we say that the component must be re-rendered. So click tag, update is called, add tag clicked is the enumeration, and matches. Here we match this code. The state is changed, and we return, okay, you should re-render. When it re-render, the view function is called, and everything here is run, is called. So all this code is run, and because the tag input visible this time is changed, it will create this HTML instead of this. So in this moment, we are saying that we are seeing tag input visible false, and it is why we have add tag clicked, this button here visible, and not this button here visible. When tag is clicked, this state is changed, so when view is called, this is rendered. Okay. This is how updating components work. It seems to be a lot of to have a lot of jumps, but I find it very simple, because you change something and then you have to re-render everything. So the code is more, sometimes is more clear. Rust is, in this case, not the terse language, but it is very clear what is happening. View just take the state and the properties, and based on the state and the properties, render something different. Okay, we have another 15 minutes, and I want to show you the authentication, how authentication works, because it is very powerful, Rocket and with authentication. Okay, say that I remove my cookie because I'm using cookies now. Sorry. The cookie has been removed, so now I have to log in. What happens when I log in? See, this is handled by the main application. It is in the state. And here we say login needed. It can be true or it can be false. At the beginning, it is true. So the view say if login is needed, show me the input, and this is the input we are seeing. Okay. When the input changes, for example, when I write something, this call on change is different only when I click outside after having changed it. This callback is called, and message login here is entered by the update function. So here the password is pass. I click outside and onChanged is triggered and login message arrived to the component. What happens now? Changed data is just a type that described the onChange event. So this is something you find in Yew HTML module. And here I create a new instance of a type credential where there are username and password. And I send it to the user worker. Here the worker receive it and make the right request to the server. In that case, it is login with the credential, login code API login. Now we see what happens in API login, in Rocket, in the server side. So login is here. It is a post method. It has a post method. And we say that we want credential provided as a JSON with the credential serialized. And we also see that credential must be in the body. When you see these in the, above a route, it means that this parameter is provided by the body of the HTTP request. We see here that this is the request was done. And in fact, This is the response. No, sorry. This is the request, password and username. These are the credentials. Credential is just a type that implements serialize and deserialize. Okay. But the powerful thing of Rocket here is API RS. The powerful Rocket authentication here is that this handler is called only if there is a JSON with that can be deserialized in a credentials type. And here, what happens when we check? We do a simple check here. Normally, you would have done it with a database. We just add a cookie. A private cookie is a special cookie which is encrypted and cannot be tampered by users. It is encrypted and signed. And then when we call any protected endpoint, sorry. Sorry, it was my daughter. Okay. I was saying about authorization. So when we access a protected, when we want to protect an endpoint, an handler, we just say that we want an authorized user. We don't even have to use it, but Rocket ensure that there is an authorized user. This is called request guard. How can it be possible? Okay, just say how it is implemented. Authorized user is just a structure with a username, but it can only be created from a valid request. So we say that authorized user can be created from a request, and the request must have cookies, and there must be the before created cookie, and it must match our user. So only if the cookie exists and is signed correctly by our server, and it is all done by this cookie structure. Only in that case, this from request is as a successful outcome. Otherwise, it will have an error outcome with a status unauthorized. What happens? Happens that when we call, when we put this here, the page cannot be accessed if the request cannot get the right cookie. So you don't have to check if you in each handler if you have an authorized user, if the name matches, etc. But you just have to put the right type here, and Rocket do all the things. And I find it very powerful. Now, we have only 5 minutes. If you have questions, I know I have gone too fast in the last few minutes, but if you have questions, now it is the time.
All right, while we are waiting for our participants to type their questions, I want to just say thank you so much for coming and giving your workshop. Even though this year we have live virtually, we are still very happy to have you come to RustLab.
Thank you.
Of course, of course. Okay, no questions just yet. So I'll just take this moment also to say, was there anything else you wanted to add about your participation in RustLab or anything else you wanted to mention?
Oh, I want to say that if there are other questions, they can. You can ask me privately. You have my GitHub or LinkedIn contacts. You can ask me anything. I'm available.
Fantastic. Great, great. So everyone, if you hear that, please contact him on on GitHub. You have his contact there, also LinkedIn. Okay, we do have a question from Jonathan who says, will you be completing the repo so we can play with the end result?
Okay, the repo is already completed and is private, but I will make it public in a few minutes.
Awesome.
And I just put in the chat the new, or you can just go to my GitHub and you will find it. Okay.
Great, thank you for that. All right, well, okay, much appreciated also by Paul. Wonderful.
Wonderful.
Okay, well, since it doesn't seem we have other questions so far, I guess we can actually end a minute early or so.
Okay.
Fantastic. Well, I want to thank all of our participants for coming and also to Alessandro for your wonderful workshop. It was awesome to hear about that. So enjoy the rest of your day and hope we see you for the next edition.
Thank you.
Great. Thank you so much, everyone.
Goodbye to everyone. Goodbye to everyone.
Great.
Thank you so much.
Thank you. All right, everyone. So that concludes day 5 of RustLab. We'll be waiting for you for the final day, which is tomorrow, which will include a talk at 12:40 by Joshua Woods, Designing Tide, followed by Modern Full Stack with Rust, Writing Reliable Code by Cameron Manavian. And then finally, we have Using Rust from JS, a real-life case by Nicola Martino. And stick around also for the closing of the conference that will happen after our last talk at 4:15. And we'll talk to you then. Have a wonderful rest of your day. Thank you. Goodbye.